about how to identify the type of hybridization in a carbon-carbon bond. Okay, so remember there are many ways to identify the type of hybridization in carbon-carbon bonds, but I'm going to teach you a very simple technique now. So basically there are three types of carbon-carbon hybridization. We have sp hybridization, sp2 hybridization, and sp3 hybridization. Okay, remember that the 3, the 2, they are superscript. And for the sp, we do not write sp1. No, that does not exist. So we have sp hybridization, sp2 hybridization, and sp3 hybridization. Let's take a look, for example, let's take a look at this compound. For example, we have this carbon, we have H, we have another carbon here, we have another carbon. Let's see, we have a double bond here, we have another carbon, we have a carbon here, we have another carbon, we have carbon. Let's see. Okay, let's see. Okay, let's see. If you take a look at this, the tetravalence of each carbon atom on this compound is satisfied. Each carbon is surrounded by 4 bonds. Okay, how do we identify the type of hybridization on each carbon? Carbon-carbon. What is the hybridization of this carbon? What is the hybridization of this carbon? This is a carbon-carbon bond. What are the hybridization on each of these carbon? Carbon-carbon bond. What type of hybridization do we have on them? Carbon-carbon bond. What type of hybridization? Carbon-carbon bond. What type of hybridization? Carbon-carbon bond. Carbon-carbon bond. Carbon-carbon bond. Okay? The simple technique to identify the kind of hybridization is that if the carbon is surrounded by all single bonds. See? If the carbon is surrounded by only single bonds, only sigma bonds, which we will talk about in another session. So if the carbon is surrounded by only single bond, that carbon is said to have sp3 hybridization. Okay? For example, look at this carbon. This carbon is bonded, has 3 bonds here, multiple bonds. So this cannot have sp3 hybridization. This carbon, on one or to the right, it has 3 bonds. To the left, it has just 1 carbon-carbon bond. Remember, we are only considering we are considering the hybridization of these carbons. Look at this carbon. It has 1 single bond on the left, multiple bond on the right. This cannot have sp3 hybridization. Okay? Only single bond. We call it what? sp3 hybridization. So this carbon cannot have sp3 hybridization. No, not this. Now let's come to this carbon. If you take a look at this carbon is only surrounded by single bonds. So what type of hybridization do we have on this carbon? We say is what? sp3 hybridized. If you take a look at this carbon, it's also surrounded by only single bonds because you have 3 hydrogen. And remember that hydrogen is always single bonded to carbons. So if we have 3 hydrogen, which means this carbon, if we erase these 3 hydrogen, we can do it this way. So which means this carbon is also surrounded by single bonds, no multiple bonds, no double bond, no triple bonds. So which means this carbon is also sp3 hybridized. Let's take a look at this carbon. Look at this carbon. Single bond here, double bond here. This is not sp3 hybridized. Look at this carbon. Double bond on this side, single bond here, single bond here. Because it does not, all the bonds surrounding this carbon, they are not single bonds. Okay, because it has double bond on one side, single bond on the other side, so it is not sp3 hybridized. This carbon, with the same reason, because it is surrounded by only single bonds, is single bonded to hydrogen 3 times, and it's single bonded to this carbon. So this carbon is also what? sp3 hybridized. This carbon is also sp3 hybridized because it's surrounded by only single bonds. So this carbon is what? sp3 hybridized. If you take a look at this carbon, it's also single bonded. Single bonded to 3 hydrogen atoms and single bonded to 1 carbon atom. So the same with this carbon is also what? sp3 hybridized. Now let's go to sp2. When carbon has at least 1 double bond attached to it. Yes? And other bonds are what? Single. The other bonds may be single bonds or also double bond. But make sure that no double bond, no triple, no triple bond, of course. And of course it will not have triple bond because it's logic. It's logical. Look at it. If a carbon is bonded to two bonds, is double bonded to another carbon, definitely it cannot have a triple bond because it cannot have a triple bond because look at this 1, 2, 3, 4, 5. It will not be satisfying the tetravalency of that carbon. Okay, so let's take a look at this. In order for a carbon-carbon bond to be what? sp2 hybridized, we must have at least 1 double bond attached to the carbon and then no triple bonds. Okay, no triple bonds. And so let's see. Look at this. This is a triple bond. It cannot be sp2. Let's see. This is on this side, this carbon. On the left it has double bond. On the 2 remaining bonds are single bonds. So this cannot be sp3. This is what? sp2 because it has at least 1 double bond attached to it and no triple bond. Look at this carbon as well. It has at least 1 double bond attached to it, no triple bond. No triple bond. So it's sp2 hybridized. Okay. Now for sp3 hybridized, the carbon must have a triple bond. Triple bond. Okay. And if you take a look at this carbon, what is the hybridization of this carbon? sp. What is the hybridization of this carbon? sp. Do we have another sp, a carbon that is sp hybridized? No. Okay. Remember, there are many methods to do this, but this is a very simple way to identify the types of hybridization in a carbon on a carbon atom.